Hello dear students, in this class we are going to discuss definite integration previous year questions. Now take a look at here. First question, prove that integration a to b f of x dx is equals to integration of a to b f of a plus b minus x dx. We have to prove this, okay? Hence evaluate pi by 6 to pi by 3 integration of 1 by 1 plus root over tan x dx. So here lower limit, upper limit. Let us consider in this LHS is this part and RHS is this part, okay? Now we will consider RHS. So consider RHS. Integration is a to b f of a plus b minus x dx, okay? So assume, okay, let a plus b minus x is equals to t, substitution method. Differentiation of constant is 0, differentiation of constant is 0, differentiation of x is minus dx is equals to dt. So in the place of dx, can I substitute minus dt? So we can substitute. Now we have to change the limits also, okay? So here upper limit, this is upper limit, lower limit, upper limit. So here lower limit is x is equals to a, substitute, then minus a plus a get cancelled, then t is equals to b. Upper limit is x is equals to b. If I substitute in the place of x, minus b plus b cancel, t is equals to a. Hence therefore here limits got changed. So from here we can say integration lower limit is b to a. In the place of a plus b minus x, substitute t. In the place of dx we can substitute minus dt, okay, minus dt. So I'm writing minus outside. So because of minus, we can change the limits. Okay, b to a is there, right? Lower limit b, upper limit a is there. So we can change limit because of minus. So in order to remove the minus, using property, we can change a to b f of t dt. Okay, f of t dt. If I replace t with x, then it will be directly a to b f of x dx, right? So this is RHS. LHS, sorry, this is LHS. Therefore this is LHS. LHS is equals to RHS. Hence this is a proof. Here we have a question, pi by 6 integration pi by 6 to pi by 3 1 by 1 plus root over tan x. So here let us consider the question I, okay? So I is equals to pi by 6 to pi by 3 by 1 plus, can I write this as root sin x divided by root cos x. Tan can be written as sin by cos, right? Now do LCM. So if I do LCM, what I'll get, I is equals to integration pi by 6 to pi by 3 1 by root cos x plus root sin x divided by root cos x dx. So this root cos x goes to the numerator. So I is equals to pi by 6 to pi by 3 root cos x divided by root cos x plus root sin x dx. Now we have to apply the property here, okay? So if I apply the property, what is the property? A to b f of x dx is equals to a to b f of, in the place of x we have to replace a plus b minus x dx, okay? So this is the property. So here x is changing to a plus b minus x. So here x is changing to the place of f, pi by 6. In the place of b we have pi by 3 minus x. So x is changing to pi by 2 minus x, okay? So x changing to pi by 2 minus x. Now we are writing here I is equals to pi by 6 pi by 3 root over, x is changing to cos of pi by 2 minus x divided by root over cos of pi by 2 minus x plus root over sin of pi by 2 minus x dx. So from here cos of minus pi by 2 minus theta is sin theta, okay, sin theta. So cos of pi by 2 minus theta is sin theta. Because of 90 cos changes to sin, 90 minus theta lies in first quadrant, positive. So we can write here next is sin of pi by 2 minus theta is also cos theta, okay? So because here 90 minus theta first quadrant, because of first quadrant positive, because of 90 sin changes to cos, therefore I is equals to pi by 6 to pi by 3 integration root over sin x divided by root sin x plus root cos x dx. Now what we have to do, before applying property equation 1, after applying property equation 2. Now add 1 and 2, add 1 plus 2, okay? I plus I is 2i. Integration pi by 6 to pi by 3 root cos x plus, see here, numerator we are adding root cos x plus root sin x, because denominator terms are same, sin x divided by root sin x plus root cos x dx. So these two terms get cancelled one time. So 2i is equals to integration pi by 6 to pi by 3 1 dx. So integration of 1 dx is x. From where to where the limits are pi by 6 to pi by 3. So upper limit substitute pi by 3 minus pi by 6. So this is 60 minus 30. What is 60 minus 30? 30 pi by 6, okay? 60 minus 30, 60 minus 30, 30. So 30 is pi by 3. So from here I is equals to pi by 12. 2 6 are 12. So therefore the question I is equals to pi by 12 is the solution. This is the solution. I is a question, pi by 12 is the solution. Here we have a second question. 0 to pi by 2 x sin x cos x divided by sin to the power of 4 x plus cos to the power of 4x. So dx. Here let us consider the question is I. Okay. So I is equals to 0 to pi by 2 x sin x cos x divided by sin to the power of 4 plus cos to the power of 4 dx. So apply the property. 0 to a f of x dx is equals to 0 to a f of a minus x dx. This is the property. So in this property x is changing to a minus x. X is changing to a minus x. So here in the place of a we have pi by 2. So x is changing to pi by 2 minus x. So we have to replace x. 0 to pi by 2 minus x sine of pi by 2 minus x cos of pi by 2 minus x divided by sine of pi by 2 minus x plus cos to the power of pi by 2 minus x dx. So from here on sine of pi 90 minus theta cos of pi 90 minus theta sine theta. Okay, so we have to replace this. I is equals to 0 to pi by 2 minus x sine changes to cos because of 90 cos x. This is sine x divided by sine because of pi by 2 sine changes to cos to the power of 4x plus sine to the power of 4x dx. Okay, so this is before applying property equation 1. After applying property equation 2 at 1 and 2. Okay, 1 plus 2. So 1 plus 2 left side I plus I is 2i is equals to integration 0 to pi by 2. There we have x sin x cos x divided by cos to the power of 4x plus sine to the power of 4x plus this is pi by 2 minus x into cos x sin x divided by cos to the power of 4x plus sine to the power of 4x. Okay, dx. Here denominator same we have, we can add numerator directly 0 to pi by 2. So x sin x cos x. Now multiply these two terms into pi by 2 sin x cos x minus x sin x cos x. Now these two terms multiply to x divided by cos to the power of 4x plus sine to the power of 4x dx. So cancel these two terms, pi by 2 outside. So here 2i is equals to pi by 2 outside. 0 to pi by 2 sin x cos x divided by cos to the power of 4. This is right. Can I write 1 minus? First of all we will write this. So I am writing here cos to the power of 4x as a 1 minus, first of all, cos square x whole square. From here cos square is 1 minus sin square x whole square. Okay, so I'm replacing cos to the power of 4 as 1 minus sin square x whole square. Okay, plus in the place of sin to the power of 4 I'm writing here sin square x whole to the power of 2 dx. So from here what we are seeing sin cos is there. Now let us assume here substitution method. Okay, substitution method. Sin square is equals to sin square x is equals to, let sin square x is equals to t. Okay, differentiation of sin square is differentiation x to the power of n is 2 into sin x whole to the power of 2 minus 1. Inside differentiation of sin x is cos x differentiation is dx and t differentiation is dt. Okay, so 2 sin x cos x cos x dx. In the place of sin x cos x dx, can I substitute dt by 2? Dt by 2. Yeah, we can substitute. In the place of sin x cos x dx, we can substitute dt by 2. So now limits we have to change. Lower limit. What is lower limit here? X is equals to 0, right? X is equals to 0, substitute. X is equals to 0, substitute. Then sin square 0 is equals to t. Therefore, sin 0 is 0. Next, upper limit. Upper limit x is equals to pi by 2. Substitute. In the place of x, pi by 2. Then, in the place of x, pi by 2. So t is equals to sin pi by 2 is 1. So we have the limits, lower limit 0 to 1. Limits got changed. Now you can replace. 2i is equals to pi by 2 integration 0 changing 0 to 1, right? Lower limit is 0, upper limit is 1. And next, because of in the place of sin x cos x dx, we can substitute dt by 2. So dt by 2 whole divided by 1 minus t square, 1 minus t whole square, 1 minus t whole square plus t square. Because in the place of sin square we are substituting t. So this is simple. dt already we wrote. So 1 by 2 outside, 1 by 2 outside. So pi by 2 to the 4. Integration 0 to 1, 1 by, this is a minus b whole square, a square plus b square minus 2ab plus t square dt. Why we are doing t square? We have t square here. Next, 2 send it to right side, pi by 4 to 8. Next, 0 to 1, 1 by, we have here t square plus t square, 2t square minus 2t plus 1. So we have to consider here, consider a quadratic, consider 2t square minus 2t plus 1. Do completing square method. Okay, take 2 common. Then t square minus t plus 1 by 2 A square, first of all we have to write A square minus 2AB. A is t, B select in such a way that you should get minus of t. So here we have already 2t. So what I'm doing here, multiplying 1 by 2. So 2 to cancel, you'll get minus t, right? So this is possible. B is 1 by 2. Adding B square, subtracting B square, plus 1 by 2. 2. A square minus 2AB plus B square is A minus B whole square. A minus B whole square. This is 1 by 4 plus 1 by 2. So 2 times of t minus 1 by 2 whole square. Minus 1 by 2 plus 1 by 2. Minus 1 by 4 plus 1 by 2 is plus 1 by 4. Plus 1 by 4. So this is in the place of quadratic you can substitute now. Okay. So in the place of quadratic I'm substituting this entire thing. Or else multiply, no need of multiplying. Okay. So I'm substituting in the place of quadratic. So here I is equals to pi by 8 integration 0 to 1 by, in the place of this quadratic I can write 2 times of t minus 1 by 2 whole square plus 1 by 2 whole square, because 4 is there, right? We can write here dt. 2 outside, so pi by 2 8s are 16 integration 0 to 1 by t minus 1 by 2 whole square, t minus 1 by 2 whole square plus 1 by 2 whole square dt. Now we have, this is in the form of integration 1 by x square plus a square dx. So what is the formula? 1 by a tan inverse x by a plus c. This is the formula. Okay, so use this formula. So here we can say pi by 16 1 by a. So in the place of a we have 1 by 2 tan inverse x by a. X is t minus 1 by 2 divided by a is 1 by 2. From where to where the limits are 0 to 1. So 2 8s are 16. Pi by 8 tan inverse 2t minus 1 by 1 after cancelling this, right? So 0 to 1 substitute upper limit. So here we can say tan inverse of 1 substitute in the place of t, 1, 2 minus 1, 2 minus 1, upper limit done, minus lower limit 0 substitute in the place of t, 0. So minus 1 remains, right? So here we can say upper limit done, upper limit done, minus lower limit, tan inverse of 0 substitute in the place of t. So 0 minus 1 minus 1. So this is upper limit minus lower limit done. Next pi by 8. So tan inverse of 1. Tan inverse of minus is minus tan inverse. Minus plus tan inverse of 1. Okay. So when you'll get 1 in tan, pi by 4 plus pi by 4. Okay. Pi by 4 plus pi by 4, pi by 2. So pi by 8 into pi by 2, which is pi square by 2 8 is 16 is the answer.